you guys as well, potentially. All right, 5 seconds, guys. 1 second. All right, go ahead.
Sweet. It's been an eventful week. There was a hack attempt against our chain, and I'm happy to report that the technical and organizational security was quite good. They got away with less than 0.1% of the funds, which was roughly equivalent to what a security audit would have cost. Except it was a real world security audit. So I was happy. I was happy with the results. But that's been taking up quite a few cycles. Apart from that, my main update is that I have just been focused on a lot of calculation on this on the trace monoidal stuff. That's my main technical update.
Can we hear a bit about the calculation?
Yeah, sure. Right now, I'm going through very, very careful axiomatization that is diagrammatic, that was developed by Kuka and Kissinger. The axiomatization is in a book. Let me see if I can just turn the screen on and show you the book. Hang on a second. Oh. So hang on. I don't know if there's enough light in the room, but let's try it. Zoom. Camera on. Turn the camera around. And I don't know if you can see that in the light. So it's called Picturing Quantum Processes, because they're largely using the symmetric monoidal framework to reason about quantum mechanics. But the diagrammatic notation that they develop is perfect for trace monoidal categories. So essentially, what I'm doing is going through and giving interpretations of all the diagrams, or all the basic building blocks for the diagrams, and then checking the equations to make sure that my interpretations hold. So I've got a basic interpretation, but there are a couple of places where even though the equations are true, they're true in a kind of degenerate way. So I'm less satisfied by the calculation currently. So I'm kind of thinking and pondering as to whether or not that's the case. Essentially, what it comes down to is whether or not one believes that going across the wires in the diagram takes time or not. So what do I mean by that? I'll turn the camera back off. So what I mean by taking time is, does it cross a four comprehension to cross a wire, which is essentially a transactional boundary. So when you cross a wire, are you crossing a transactional boundary, or is it simultaneous? In which case, it looks more like a big sum. And there's a way in which the output and the input appear simultaneously. It's more like an entangled state or an EPR kind of situation, rather than a causally connected kind of situation. So that's what I'm kind of looking at in terms of the place where there's a degeneracy. So that's my technical update. Does that make sense? Can people hear me?
Yeah, we can hear you.
Okay. Vlad, does that make sense?
Glad you there. Hey, Danny, what's up?
Yo, potentially bad audio, but I'm here to listen.
Okay. Well, that's my update. We can move on to others. Hopefully, we get Vlad back.
My update's pretty short and quick. I was on vacation for the last 2 weeks, so I didn't do a whole lot. But I'm back, and I'll be posting that blog post that we started working on before I left. I think there's a lot of comments and edits that have been made to it, so I'll review those and make sure that it looks good and should post it by the end of the day. I had also left something running while I was gone from my simulation engine that I demoed a little bit previously and what the blog post is based on. And my preliminary finding on that is the protocol might encourage latency instead of liveness in a certain particular way, but it's all sort of preliminary. I just scrolled through the numbers quickly when I got back, but I'll maybe have something more detailed to say about that next week.
Cool. Thanks, Michael.
Cool. On our end, we have kind of a new model where our validators can live in different threads and communicate via kind of a more abstract network layer, and they can think for themselves rather than kind of a central coordinator. So they're kind of in their own world, seeing the messages. And now we're working on how to specify validator strategies. Like maybe they're trying to form some sort of DAG, but only willing to wait a certain amount of time and make decisions on that kind of stuff. And hoping to have some cool experimental results around latency and venality and like their ability to form DAGs and things like that. So under different network conditions. And so I hope to have some cool experimental results for y'all next week, or I guess maybe the following, if that's Christmas. But keep you updated. And
Hey guys, do you guys hear me now?
I think Nate's been doing exams, but he's been reworking kind of this language, but more generally a state language to specify state not only in the blockchain version of this, but kind of in these arbitrary consensus, Casper CBC consensuses. So cool. That's all I got on our end.
You guys should really start looking at the Rolang stuff, because that's exactly, everything you're trying to do is what kind of falls out naturally with Rolang.
Well, I mean, the Rolang is one of many things that we can replicate with the correct architecture consensus protocol.
Oh yeah, of course.
I mean,
it's sort of naturally.
Sorry, go on.
Yeah, I hear you. I've been meaning to, and I will. Thanks.
Yeah, from my point of view, the replicating the row calc VM is something that I could see how to do much more easily than replicating the transaction system with the rules and the whole block aggregation thing.
Yeah, no. What I meant was something different, which was at the implementation level, not replicating the row calc VM, but using
I see.
Casper Rolang to implement Casper, which is what we're doing.
Oh yeah, I mean, I think that I misunderstood. Okay,
yeah. Because it gives you like like every validator is a contract. It's a Rolang program, which is necessarily going to be communicating with all of the others via message passing, and that's already integrated with the messaging system and so on.
Sure. I mean, we have, you know, this Python object, and you know, it's not so bad.
Yeah. Well, we'll.
As far as I'm concerned, people should implement Casper in all languages.
Mhm. Yes.
Not necessarily use it, but you know, just for educational purposes.
Yeah. Understood. Understood.
So I have an update. I've been working on sharding stuff still, and it's been coming along pretty well. I've been, you know, making progress and trying and like learning to understand some of the trade-offs, you know, differences between my old sharding approach and my current sharding approach. Talked a little bit about that last week, but my current sharding approach it guarantees atomicity of transactions using the fork choice rule, whereas my previous sharding approach, you know, also did the same thing, but it didn't. It guaranteed it eventually, as opposed to immediately. It was kind of optimistic and error correcting, whereas my current approach like never makes mistakes in some way, right? It's and as a result, you know, I mean, it's kind of a classic trade-off, but things move a little bit are actually kind of slower than the previous sharding solution, because for cross-shard communications, you actually have to involve a block from a higher level shard, and whereas previously it was only in the failure mode that needed to happen. And so, you know, it turns out that, okay, well, if you do like a binary tree of shards, and you allow all of the leaf shards called all of the leaf shards, then, and you assume that all of them call to each other equally frequently, then like half of the calls would go through the root shard. And that's, you know, unfortunate in some way, because it means that, you know, we don't actually get much of an increase in capacity for cross shard calls, even though we may get a lot of capacity increase overall the system. You know, for cross shard calls, it's not a huge capacity increase. You know, it's like a 2x increase in, you know, at least based on this really simple vacuum output. I mean, in reality, it would be even less. But if you don't have arbitrary random calls for the shard, and instead you can do load balancing to minimize the amount of calls over the root shard or over shards that are like, you know, ideally we'd have fewer calls between shards that have a higher, you know, lowest common dominant consensus protocol, or, you know, lowest common shard or lowest. So and then in that case, you know, you can imagine with some load balancing that we get much more substantial gains from the tree structure than if you know, half of the calls had to go all the way to the root and back down, or at least would have to be, you know, their load would have to be kind of synchronized with the block of the root. You know, basically, no matter which way you slice the pie, it's pretty much is like there needs to be a block at the root to guarantee the atomicity of a call from one shard to another shard, which, you know, has like a different, you know, different path in the root. So that's kind of some observations about like maybe some of the latency, or sorry, some of the bottlenecks in this like really simple sharding solution that I'm working on. You know, related thing, I kind of worked out actually that we could, the protocol actually works out with the soft fork on Bitcoin. So, you know, I described the sharding protocol last week where you do a fork choice rule on the root chain, and then you follow the latest blocks which point to the first level chain, to the blocks they're pointing to, and then you do a fork choice rule starting from there, and then so on, like further and further down the sharding system. Basically, like, you know, the security of the root chain really is, you know, not more than the security of the shards, because a reversion in the root chain can revert the security of the shards. Sorry, not less than. Yeah. So the shards are not more secure than the root. Is what I'm trying to say. And so, that actually fits really perfectly well into the whole soft fork environment, where like we're never going to increase the security of the root. And then basically you can imagine there's kind of two ways that I thought of doing it. One of them is with SegWit data as a block on the lower shard, and the other is to merge line. And basically, you can create these atomic blocks. You can have this fork choice rule in a similar way, where the fork choice rule on the shard will start from the latest block at which it's pointing to from the root, and so on. There's different, and you'd only have fees on the shards, because Bitcoin with a stock fork can't actually have more issuance there. But it's all kind of fine, actually, because even if you attack the shards, no one considers them safe at all until they're a certain depth into the root anyways. Because the security of the shard is entirely dependent on the security of the root in the system. The fact that all these shards are relatively low difficulty is not a huge issue. And in fact, it's actually a nice plus. It's a lower stakes game. So it's a plus in the sense that okay, well, somehow we could have more shards at the same time. Maybe it would be better for security if they had more, because assuming that people do want to make decisions without waiver confirmation of the root, which they shouldn't really be doing at all anyways. So basically, all of the shards just piggyback off the security of the root, and you wait for just confirmations of the root, things that were committed to your shard before you actually send the good to them. And so, I don't know. It's just like another fun exercise in the world of sharding. And again, the thing I like to stress and think about all the time is how all these things kind of can be thought of and fit within the kind of estimate safety and fault protection model. The kind of safety and practice. I feel relatively confident that I can shard Bitcoin with software, which is pretty fun. It's a fun thing. I'm basically the only kind of tricky problem, and the thing that's going to make it so that Bitcoiners won't adopt it even though it's software, is that you have to so with proof of stake, normally we can assign validators to shards and say exactly who's responsible for validating what and hold them to account for that. In proof of work, as is, you can't really do that. And so unless we use non-outside proof of work for the shards, which is not unreasonable in some way, but it's not the same as it. So at the end of the day, because the instead of having a clear validation protocol, we're basically saying assume blocks are valid. Probably the Bitcoiners aren't going to like it too much. But from the point of view of just proof of work headers, right? Just from the point of view of just the consensus mechanism, the fork choice rule, and the question of whether it's safe to send the good after receiving Bitcoin from the shard. Assuming everything's valid, is I think I'm getting to a stage where I have it pretty well worked out, and where I have more and more of a handle on it. I can even soft fork starting using Bitcoin. It's pretty exciting.
Yeah, if Bitcoin had a governance model that would allow you to get it across.
Well, it does. It's not a contentious hard fork. So I just have to get the miners to agree to enforce the. At the end of the day, you have to get through the bid process. But at the end of the day, really only the miners need to enforce the terms of But yeah, so I mean, so basically the question is whether you get to the bit process, I guess. And basically you're saying like, so I feel like, you're probably right, but it's a soft fork, and so that kind of raises questions about the bit process to me. But also, it might just be not conservative enough with respect to the validation strategy. However, maybe one day we'll have journals proof of the validity of all these things, and they won't really have as much to say about that. But anyways, maybe Bitcoin Cash will be interesting.
Oh yeah.
Yeah, so I mean, if anyone has any questions about the sharding fork, with basically the like sharded fork choice rule, I'm happy to field them.
Do you have a write-up of it anywhere, Vlad, or at least something started that I could just peruse at some point?
Yeah, I can send you. Like basically messages I've sent people and drawings I've made, which should be like. Oh, actually, I have even better. I have notes I made for myself and drawings I made, and the notes are more recent, and they should be just, I guess plenty.
Yeah, cool. If you could send those my way, I would be interested in looking them over.
Let me do that right now. Actually, I'm just gonna grab my laptop and do that. But I would love to hear, Michael. You broke up when you were giving your update. You said you'd ran your experiments, and you might have found, or you might have seen something, and I missed suspense.
So in a touch more detail, I was running an evolutionary type algorithm where the strategy had a parameter that basically was how long do validators wait before spending political capital in sort of the model that Greg had proposed before. And basically, I was using the amount of rev that the validator was earning as sort of a fitness surrogate, and I let that run for a little while I was away, and it looks like it was tending towards longer and longer times the validators would be waiting before spending political capital, which would generally mean I would think longer times in between validations actually happening. But if you have a large enough pool of validators, maybe it just means that it naturally sort of builds up. One validator is having a lot of political capital, then they spend it all, and then other people pick it up, and then So I guess all I'm trying to say is that it's all preliminary, and it's possible that the tendency would be to wait a long time before validating something, but maybe having a large enough pool of validators would make that not a problem. I still have to play with it more, though. I just sort of very briefly scrolled through things and haven't looked in detail yet.
Cool. That's really interesting. So have we all gone around?
Did you hear me?
Just now I did.
Sorry, yeah, I was speaking for a little while. I think when I switch from, I think every time I put speakerphone, it screws up my audio for Zoom for some reason. I was asking Michael, when do the validators make blocks, and is that also being involved in this process?
Yeah, so to make blocks, validators spend political capital. So when I'm talking about waiting to spend, it's effectively waiting to create a block.
Okay. So it says promotion isn't a separate thing in this model. We don't have like a separate thing for promotion.
Yeah, promotion is how you earn political capital. So someone creates a block and others can promote it or build on top of it. And so basically what it looked like was going on is you would see someone put down a block with a huge amount of political capital on it, and then a whole bunch of validators would sort of pick up that political capital by promoting it. And then another huge block would get dropped. And so there was a lag in between those things happening. And that
and that's super interesting. Sorry, I have another question. Have you thought about having also like a collective factor on their fitness? Like, well, I guess what I'm saying is, sounds like, okay, they're individually, you don't have any pressure for them to say, come to consensus on blocks quickly.
Yeah, that's right. The only thing that goes into fitness in the current version of the simulation is how much rev each individual earns.
But they don't earn as a function of how many blocks they produce.
Not necessarily, because if you produce one block that has a whole bunch of contracts in it, then you could earn a whole lot of rev all at once.
Yeah. Okay. But somehow, so here's like the kind of intuition that I have, right? I want the validators to cooperate to produce as much quality for the protocol overall, in terms of, for example, things like, minimum number of blocks who didn't contribute to getting finality. There's I might have like a bunch of notions of how good it went for the system as a whole. And then I'll decide how much money everyone makes in order to maximize that as a mechanism design question. And so what I would do is I would have a fitness function as try to push people to create good effects for the whole system rather than just individually.
Yeah, no, I see what you're saying. I definitely want to add into the simulation metrics that are measuring things that are beneficial for the network, and looking at sort of how well validator behavior is getting those goals accomplished. And totally, we would ultimately want the optimal strategy to be one which scores well on all of these metrics. And so that's basically what I'm at this point. At this point is because I'm looking at sort of the very simplest version of the protocol, at least as far as I can tell. I'm sort of hoping to build up constraints over time based on metrics, based on the types of things that you're recommending, in order to ultimately drive the strategies towards the type that we want. And I'm not there yet, though, and I would love to hear recommendations for metrics.
Yeah, so
I have one. I have a recommendation.
Oh, sorry. Just one thing that I didn't get was whether or not you have pressure in terms of transaction fees. So the point is that I was driving the protocol against latency by if there's the longer the justification from last finalized block, the smaller the transaction fees. So that
yes. So I don't have anything like that implemented at the moment. Okay. And the reason I don't is because of the sorts of issues we were talking about at the retreat around sort of how you like when fees get distributed, basically, and sort of what are you calling a cycle and this kind of thing.
So that exactly. So it turns out it looks okay to distribute it in the next round.
Yeah. So This is a super interesting thing that's happening. You know, I mean, back in the day, I used to be the one who was always building economics into the protocol from the start, and you used to tell me that I need to build a second layer. And now I feel like, you know, a lot of this discussion, I feel like, could be a lot simpler if you just were happy to accept like that this layer doesn't know anything about the economics. And there's like another layer where like that like, you know, where basically the fees go to a smart contract and then we don't know what happens. But when we're working on that smart contract design, we think about things like, oh, how do we pay them to incentivize them to maximize the quality of the system? You know, rather than affecting the consensus dynamics with the public nature of things.
Well, so the reason that I base the fitness function on the earnings, the economic piece, instead of just anything purely consensus based, is because I think in reality a validator's behavior is solely economically driven. Like someone joins the network with the intent of having some kind of economic gain.
Of course, but the thing is that but ideally we know exactly what behavior we want from them, and we just disincentivize deviations from that behavior. So we don't say, oh, look, we'll pay you to produce safety. No, we pay you to follow the fucking protocol, which we mathematically calculated maximizes the best things. You know,
yeah, absolutely. I totally agree with that, and that's why I was running this simulation. Is I was trying to see where my current implementation is at in terms of what we hope the optimal behavior is and what the actual optimal behavior is. And basically we'll work on it until the optimal behavior based on an evolutionary simulation or an actual proof matches up with the behavior we want.
That makes a lot of sense also. I mean, that is absolutely yes. That makes a lot of sense. And I guess, but the thing about evolutionary algorithms is that like you need to run them a lot to make sure that you're not just running into weird quirks.
Absolutely. That's why I ran it while I was away for 2 weeks. I thought it was a good opportunity.
Yeah, it's amazing that you managed to get your code to run for 2 weeks. I would never do that. Amazing. So here's my suggestion for how to look at, or one suggestion, the cleanest suggestion that I know of, for how to look at how much a particular validator is contributing to quality, or a particular block is contributing to quality. Pretend their weight is 0, or pretend it doesn't exist, and all the blocks that point to it don't exist. Those are the two options. So basically, if you just like look at the validator set, you said, or you reassign the weights of those validators to 0, and if that doesn't change the safety, then they're not contributing. Essentially, you know, I mean, you can think about their contribution in terms of how much their weight is actually contributing to the safety of what blocks, right?
Cool. Okay. I like that.
So, and then for the block question, like which blocks so which blocks contributed? Basically, if you remove a block, what you basically need to do is remove all the later blocks from the same validator and the reference to those blocks and all the dependencies. Right. So you just imagine like if that block was never to have happened, what would this system look like? And if you have, say, like less blocks finalized, then you could say, oh, look, that block, you know, or imagine that at some height, a block is finalized with that block around, but isn't when it's not around, then that block somehow contributed to liveness, you know, or you know, the production, you know, I mean, it created safety, and therefore, you know, was the block that eventually got us there.
Yeah, no, that makes sense.
And I think there might be more analogous things. But basically, the rough idea is that we need to somehow isolate the effect that a particular validator or a particular action has on the desired outcome. Which mostly I just think about in terms of like which blocks are finalized and how much overhead there is. So, like, you know, ideally, like in some way, if we decide that we want to have minimally the minimum overhead, so like maximum throughput, then we'd want like there to be like no blocks ever not getting along exchange, right? and we would penalize when a block doesn't get in the longest chain. If we have something a little more subtle, like say we want to have finality happen at a certain rate, but not to have the overhead go above some amount. You can we can start to look at which of the blocks contributed to finality and which of them didn't, even when the rate of orphan blocks is kind of the same. And there's kind of this game of like, the more finally we can determine who contributed and who did what, the better the incentive mechanism is going to be, which means we're going to have, basically means that we hone in on malicious behavior better and identified honest behavior better, so as to not penalize the honest people, and so as to make sure that the attacker pays penalties.
Totally. Yeah, I agree with all of that. I do need to put in some metrics around like how long side chains tend to be, and like on average, for example, or the average and variance for like time to finality. These sorts of basic metrics I also don't have coded up yet, and I need to get those in there as well, so that we can start answering those sorts of questions.
I mean, and no worries, no rush. I mean, you're already doing amazing, so it's okay.
Well, thank you. I appreciate that.
Don't listen to him. It's a serious rush. We have to get this thing out by the end of the year.
Yeah, no, I mean, I hear. Listen to Greg. But also, if you get down on yourself, it's not going to help.
Yeah. No, I'm just teasing.
Yeah, I know. Well, I think we're all teasing at this point. So, does anyone else have an update? I guess that's a no.
Well, I thought it was a good session. Actually, it was good to.
Oh yeah, I actually. Wait a second. I'm going to, before we leave. Can I get the meeting ID? Or is this something that's private? Here, I'm trying to send you guys the notes on the sharding and the picture of the sharding. And I'm just like have to search for the link on my machine here.
Yeah, I mean it's in the room, so I'll put it in the chat.
I know I'm not in the room on my laptop. I'm in the room on my phone.
You want to put it on Skype?
Yeah, message me on Skype. That'd be amazing. Logging in Skype now.
Cool. All right. See you guys. Let's see. What next Monday is that Christmas?
I can check. Christmas Day is the 25th, isn't it?
Yes.
Yeah, it should be. You guys want to do one or not?
I probably should give Christmas Day to my family.
Right. Fair enough.
So I won't be here on Christmas Day, or for that matter, I don't think I'll be here on New Year's Day, which will be exactly 1 week later. So do we want to call it for 2 weeks, or do we want to, whoever can make it, just make it?
I'm fine with showing up. It really does not bother me because it's 10 a.m. on the East Coast, so But for everyone who wants to open the Christmas gifts early in the morning.
Vlad, any thoughts? I think it was that speakerphone issue again.
That's HJ, that's probably something you have to talk to Greg about, because I mean, Lika has me covered. So Greg, we still need to work out those details probably. I guess right after New Year's, right? That'd probably be the best thing to do for the conference.
I didn't see what was the question here?
Aisha says, may he join the Perm conference. I mean, as far as I know, the conference is open.
Yeah.
Yeah.
So, sorry about that. I was having the same issue as always. I think when I tap out of my Zoom on my phone, it just stops working. I was saying maybe we just move the Casper stand up a couple of days forward or back. Maybe we do it Wednesday instead of Monday. 27th and the 3rd.
Actually, that would work for me. Yeah, I can do it. Yeah, that'll work.
Yeah, it works for me too. Just need to know the dates and times. I'm assuming the same time is a different day.
Same time, different day is what I'm suggesting. Yes.
Yeah. Okay. So for the next 2 weeks, so it would be the 27th and the 3rd, and then move back to Mondays.
Cool. Yeah. I think that makes sense. All right.
Yeah, just make sure that Danny knows and all that stuff too.
Well, yeah, I'll do that. Check it out. Do you guys see my screen here?
Yeah.
Yeah.
This is my little representation of the minimum sharding kind of 4-choice rule with the binary kind of thing, where basically there's 2 level 1 shards and 4 level 2 shards, and basically some of the blocks are like the same block. Imagine their merge bind, and those blocks include the atomic transactions, moving outputs from one shard to the other. Along that line.
Cool.
And the 4-choice rule starts at the sorry, one second. The 4-choice rule starts at the blocks that are pointed, the last block that's pointed to. So what did you ask?
What did you use to draw the diagram?
Microsoft Paint.
Seriously?
Legendary, bro.
No kidding. Yeah, they have this great curved line tool. It's awesome.
Yeah, that was what I was looking at, was the curved line. I was going, holy crap, this is not, XY pick. This is not OmniGraffle. What is that?
Yeah, no, it's straight Microsoft Word.
That's awesome.
Yeah. So Michael, this is one of the things I wanted to show you. So if you take a screenshot or whatever, that's great.
All right, yep, we'll do.
And then the other thing is this text file, which I tried to paste into the channel, but it was too long. So I guess I'll just do it in multiple steps. Okay. So let's
Ça va? Ouais, ça va, bof. J'ai perdu mon passeport l'autre jour et c'est le bordel. Ah bah elle est sortie en ville avec l'école, pour la gueule et...
I think I got it. Okay, here we go.
Ouais, ça... Maintenant, je sais pas pourquoi, mais parce qu'il est perdu, il me demande des chiffres d'informations comme la date de ton
Are
mariage.
you in Romania, Vlad?
No.
I don't know what the language is.
No, sorry, everybody's just having a call here. Also, just like
I don't know if you're going to go see your family. I don't know if is your family in Romania still, or
we're in Switzerland. We're in Switzerland.
Switzerland, right? Okay, I forgot. That must be pretty badass if you're going to Switzerland for winter, though.
Yeah, it is pretty bad. It's pretty great to go skiing. Anyways, so I just published this. I just posted this note on the sharding protocol that I took a couple days ago. It's not anywhere near final or anything, and I probably should have. Now thinking back at how much work that was, I should have just put it in Google Doc. But I just wanted to make sure to do this as soon as possible, so that I don't end up procrastinating for days. So that.
Yeah, I appreciate it. I'll take a read through and maybe have questions for you at some point in the future.
You should. Are you in the Casper Discord that I started a little while ago? Hey, Greg, you should get on this.
I don't think I am. So if you could invite me to that'd be sweet.
Yeah, invite me to that. Although, yeah.
So I got I gave Meta the thing, and I thought she would have shared, but I will give the links. Basically, it's still like there's not active really yet. Basically, what I'm doing and what I expect is that there's going to be a growing rather quickly number of teams implementing the correct construction Casper. And so I wanted somewhere kind of like neutral ground that we could all kind of talk without being tied to a particular implementation, so that we could maybe have somewhere for ongoing research without worrying about backwards compatibility or maintenance versus.
Yeah, that's a good idea.
It's also easier. It's gonna be easier to invite people there than I think to anything that's associated with any cryptocurrency. From the point of view of academics and stuff. Nothing else. So I guess that's all for me then. So if we're all good to go.
Yeah, for sure. I think so. Vlad, I think I know what happened with Meta. You probably gave it to her, and then our Discord server was hacked, and so she hasn't been able to disseminate it out to the team because we've been.
No worries. I was pretty specific about not disseminating it too widely, but I said anyone who understands Casper is
Okie dokie, sounds good.
Cool. So yeah, I'll in fact, I might even have the Discord on Windows already. Okay, I don't. So I'm not gonna be able to send the thing right now, but I'll send you guys a link soon.
Sounds good.
Cheers.
Happy holidays to all.
Yeah, happy holidays, and try not to work every day.
Ciao.
Bye.
Right.